Hello, seventh graders. I wanted to take a quick moment before the quiz to talk to you about some issues that I saw through the online textbook and some of the food webs and food chains. First of all, let's make sure we understand the difference between a food web, food chain, and the food energy pyramid. This right here is a food chain. It's basically a set of four organisms that show the passing of energy between those organisms. Okay. And what you have to understand is that when we do any of these, a food chain or food web, the arrows always go in the direction of the organism that is doing the eating, that is doing the consuming. So you have to think of it as this plant is passing on its energy to this insect. Why? Because this insect eats the plant. This insect is passing on its energy to the mouse. Why? Because this mouse eats the insect. This energy is passing it, this mouse is passing on its energy to the owl. Why? Because this owl eats the mouse. So that's a good way to understand is, the energy is being passed on to the next organism. Here's an example of a food pyramid where you're seeing the different levels that can exist within an ecosystem. What do I mean by the levels? These are called trophic levels. And these are a way you can think of it is that these organisms nourish or pass on energy to these organisms. These organisms pass on energy to these organisms, so on and so forth, till we get up to our apex predators and so on. Notice that we always have less organisms up here than we do down here. That happens because of the energy that is lost in a food pyramid. And we're going to talk more about that in a moment. Down here, you can see the reason why we draw it as a pyramid because there's much less energy up here than there is down here. Okay, and we will focus on this, in the online textbook in a moment. Last not here, this is a food web. This food web, as you can see, is not as organized as the pyramid or the chains. But it shows more organisms and how they are related to each other. Again, the arrows always point in the organism to where the energy is going, the organism that is doing the consuming. So right now you can see that this fox consumes rabbits, squirrels, mice, seed-eating birds, other types of birds, and so on. And you can see how those, food webs are basically a combination of many different food chains. Now, where I saw the biggest problem was right here in this energy pyramid. And again, you can see it has trophic levels, and you can see how the arrows always point in that direction, okay, into the organism that is doing the consuming, where the energy is being passed on. Now, what you had to do here, and I think a lot of you missed the instructions, but you had to take this amount of calories, okay? That's where it's starting, at the bottom here, okay? And what we had to do was take that amount of calories and see how that fits together with the amount of energy. Basically, 90% of the energy is lost due to heat, due to thermal exchange. If you think about, any energy conversion that takes place, this is back from Unit 1, we always lose it to heat. There was always thermal energy being lost. And the same thing happens here. Basically, only 10% of the energy is passed on. So when we're starting with that, an easy way to do this, when we're starting with this 330 calories, all we had to do in this first level is multiply it by 0.1. And that basically knocks off one whole zero. So we went from 330,000 to 33,000 in that first level when these mice ate all the plants. Then when the snakes ate all the mice, we lost another 90% of the energy. So we multiply by 0.1 and we knock another zero off. Okay. Now, if the snakes were eaten by the eagles, we'd lose another one. So we're down to 330 kilocalories of energy at this point. Now, this is where it got a little tricky. So this one, you had to sort of do it in reverse. Okay. So if you multiplied 330 times 0.1, that got you 33 kilocalories. And at that point, that's how much energy, was lost. And so therefore, if you multiply or subtract 33 from 330, that gets you 297. And that's how much energy that eagle would use in its daily life processes. And so there'd be only 33 kilocalories of energy that the eagle could store, because all I did right there was subtract 297 from 330. And that gets your final answer. So basically, we're just multiplying by 0.1, and then this one you had to sort of do it in a little bit of reverse because of the way they asked the question, which is a bit confusing. I probably wouldn't ask that question on a test, but it's good to understand how much energy is lost for those apex predators. Thank you.